Okay, so as we mentioned, this equation, equation 4.4, basically is the law of cosine, because this graph basically is in the new coordinate, they should be the same. So if we write down like the scalar term, usually this part we will not write down, just because you just new to this kind of notation, I write down this. But this is redundant for the index notation. Usually they just showing like this. So given this equation, if we take the free index k as one of a coordinate, you can choose a 1 or 2 or 3, either one. And basically the right hand side, this part, we have I as the dummy index, and J is the dummy index as well. So our summation should write down like this. So your equation 4.4 should write down like this. So basically your I can be the 1, 2, 3, but basically only 1, this summation will become to the 1, because they will become to the same coordinate. And when the I equivalent to 2 or 3 different kind of independent direction, this summation will become to a 0. So basically this cosine is the angle between these two parts, just like a definition, like this. So your cosine relationship, how to summation together, what kind of value you will get, this will be the complete law of cosine. So if you write down the law of cosine in the index notation, so you will write down like this. So basically this is the equation 4.1. We just write down also the Pascal theory. So basically here with the 3 term, if you have a 3 direction, okay? It's not just one, because similar like this, they have a summation here. So J will be the dummy index. Similar for this, we shall have 3 different directions, but 3 different directions cosine theta summation will become to a 0, similar to this one. So this will be the complete, the law of cosine should be like this. Okay, so the final part is we just use a different kind of way to present law over cosine. This is we choose just the fixed direction. For example, you choose the new independent direction 1 prime, or the new independent, this direction is alpha. You can relate this to the new independent coordinate, either one, alpha, beta, gamma, or similar to the 1 prime, 2 prime, 3 prime. We just choose the one over that. And for you choose a different kind of coordinate that you can choose by k, because the k is a free index. So this I can be the alpha, beta, gamma, or they can be the 1 prime, 2 prime, 3 prime. Okay. So for the k, if they choose, then basically your law of cosine should present like this way. So you can see this way is similar to the definition of a data function. So if these two values are the same for this k equivalent to I, then they will become to 1. Otherwise, they will become to a 0. So this is also the definition of a coordinate data function, just like we mentioned before. So if you write down this cosine law summation, then we can get the relationship like this. So if we further to simplify, this is like after transformation, then go back to the original coordinate, then use this kind of data function. Okay, so this section we are define the relationship between the law of cosine. So law of cosine, complete law of cosine should be like this two. This is the complete of a law of cosine. And the layer relationship is related to the coordinate data function. Okay? So also the index notation we can use for the vector, for the addition or the multiplication. But here I will be very quick to show that. Maybe the detailed practice you can practice by yourself. Okay, so this index notation for the vector, of course, is quite convenient. But some purpose we want to use this index notation is because we want to use this in the tensor because they maybe create more direction. So for the vector, the simple way, one is you multiplication by a scalar. So scalar is just amplify every term with the same scalar. Or addition, I think this is the most simple operation for a vector. And another vector is the inner product of two vectors. Usually it's a dot operation. So the dot operation, usually if we use a symbolic notation, is write down like this. And for this dot notation, if we write down like the index notation, basically we just write down like this, the UI dot vi. I is the bounding index, so you need to summation. So this is a scalar term. Usually we don't write down this scalar term because the convenient for this just only this one. Then this dot product, basically in the space is an invariance. So that's mean this scalar value doesn't change with a different kind of coordinate system, no matter your coordinate system, how to notation. So you can use the original coordinate, use the I. If you choose the new coordinate, you have a new value, like the Z prime. So you can use today, we are transform to the new coordinate. For example, your original coordinate I, then you transfer to the new coordinate. You use this to get a new coordinate system. So basically, original coordinate and the new coordinate, they should get the same value, no matter how you rotation for the inner product. Okay? So if we use the index notation today, we are talking about this cosine law. That would be very convenient. You just see. Okay, but I think if you are new for this, you probably need to practice. You need to practice what this means, how we present the new coordinate. Okay, because you have two different coordinates to show the value in the vector. So basically, this term is different from this term because there are two different coordinates to describe the same vector. Okay? But the product for the two direction, no matter how this coordinate change, they will get a new result. So this is convenient. We use the index notation, we can show this. Okay. But more powerful, the usage is for the tensor. Because the tensor, they will create a new direction. So for the tensor, we also can use this index notation to show some kind of operation in the tensor.
I see that formula is the U should be V, right?
U.
And the right side, the CK crown I.
Oh, yeah, you are right. Okay. Yes. This one. Yes. also, I need to remind you, if you look the textbook by the Penton in the library, they also have some typo. Typo is maybe like a plan. Maybe he forgot this plan, or yeah, I think that's quite common way. Use some they have some typo. Okay, so if you are confused the meaning to you, you better to try to figure out. So make a note by yourself or make a copy for that textbook, then you can change the typo one. That's my suggestion. And I'm not quite sure the new version, because the new version is a digital version. Do they change all the typo? But I think it's very difficult. All the textbook has a typo. So don't completely trust the textbook. But we can say 99% of the textbook is correct. So he still get a 99 score. It's pretty high. Okay? But you ask for 100% without a mistake and the typo. Maybe that is too strict. Sometimes just like we ask ourselves, take an exam, 80 score maybe to us is good enough. Okay? So just allow some kind of a typo in the textbook. So similar for this. Okay. Okay. So later on, we will first introduce the purpose and some kind of property of a tensor and relate to the fluid mechanics. Then we will talk about a little bit their algebra, similar like the vector. But I will let you two projects. That will be more important.